Now that we have seen how to get started with exploratory analysis with data, we get to the most attractive part about our course, which is like doing data science, machine learning. In this section of the course, we will introduce you to what is machine learning and guide you through examples of machine learning. Additionally, we will talk about different kinds of tasks in machine learning and get you up and running with how some simple yet useful machine learning algorithms work. Finally, we will take a deep dive into some advanced concepts in machine learning and of course how to implement them and work with them using our familiar credit card default dataset that we have. Machine learning. Over the years, there has been many definitions for what it is and what is not all about. So two perspectives from two pioneers of the field stands out. The first one by Arthur Samuels way back in 1959. He says it's a sort of an abstract definition which claims machine learning to be the field of study that gives computers the ability to learn without being explicitly programmed. Now the second definition, more recent, comes from Professor Tom Mitchell from Carnegie Mellon University, and the professor talks about an experience that a computer learns from performing a task which has an associated performance measurements with it. The machine can learn with its performance in doing a task and improves its performance. So a few examples of machine learning that is being used and we are part of it in our day-to-day lives. So if you would have already noticed in Google can mark certain emails as spam. The spam filtering is one of the many cases where machine learning has been extremely helpful in achieving really good results. And not just Gmail, any popular email service provider that you see nowadays can mark emails as spam or not with a reasonable degree of accuracy. And if you have ever wondered how popular e-commerce websites can come up with surprisingly good recommendations for products that you wish to buy. This is again done by some very clever applications of machine learning algorithms in the backend. And also machine learning algorithms can now classify handwritten digits with nearly 100% accuracy. Add to this, if you want to know about the ABS on your cars, autopilot on Tesla cars, self-driving cars from Google, and pretty much the list is very big when it comes to the applications of machine learning. Though I believe that we don't get into the details of every application, machine learning has touched all of us in one way or another in our lives, to be honest. And this field is not a new field by any means. Over the last couple of decades, machine learning has combined ideas and methodologies from many different kinds of fields like probability, statistics, computer science, computational biology, and much more. Probability, statistics, and computer science these three basically form the backbone of modern machine learning theory. It also borrows ideas from biology, genetics, clinical trials, and many other fields from social science. The advent of modern computing power has helped in spurting machine learning. Anyone with just a credit card can just span up a cluster from one or more web services available, ranging from basic to an advanced specification, and these enterprise class hardwares are just available to our customers in a fraction of minutes. And additionally, these good results on problems considered difficult to solve historically has given machine learning a lot of popularity in the press. And most importantly, everybody sounds to be talking about it these days. So, where and how do we get started in learning with machine learning? The starting point we always advise is a question with a specific business context in mind. Why is image recognition important? It's not because it's cool to do. It's because image recognition helps solve a business problem. Why do you think predicting whether a customer will default in his credit card payment is useful or not from the business perspective? No, that's the crux of starting with machine learning. Once you have a question, the data relevant to the question needs to be gathered. Historical data helps the machine learn from it. Once the machine learns from its historical data, it needs some additional data to determine how well it has learned. Think about a semester-long course in any subject, say probability, or for that matter the course that currently we are doing. There is classroom material that helps the student to learn each concept along with some real life examples. Once the classroom lecture is done, the students get evaluated based on the examinations at the end of this course. What's important is like the questions in the final exam need not necessarily come from the material that you have studied. It's exactly the same scenario here. So, how does data look like? Raw data might come in all sorts of different formats, and here is an example of an email that is probably not a spam. This data for one email, as you can see, this is a bunch of text along with sender and the receiver information. Reading through the text, you can guess that this is probably not a spam. It then means that this raw data contains useful information about the email being a spam or not a spam. Our machine learning algorithm has to do a good job in extracting those key informations out of this piece of unstructured raw data. Now let's go on. Here is an example of an email that definitely looks like a spam. Why is this a spam? The sender, the email text all contain some useful information about the legitimacy of the email. So the question now is, how do we get a machine to extract information out of the raw data that will help it learn and solve a specific problem? So here comes feature engineering to rescue with us. The conversion of raw data to useful machine readable information features is called a feature engineering. You have to engineer a feature out of the raw data. Remember, during the exploratory analysis, we took a average bill amount for each customers over the last 6 months. That is also one form of feature engineering. We are not just limited to taking averages for the purpose of feature engineering. The number of features is only limited by your creativity and your imagination. How you perform feature engineering on a data set, it has a tremendous impact on your final results. So the starting point of feature engineering is to go from seemingly unstructured data to something that is more tidy, clean, and structured. If you can recall our credit data, when you read the data in pandas and printed its shape, it's about 29,000 odd rows and 25 columns. Each row of the data was a customer and each column has some information about the customer. This rectangular format with the rows and columns is called a tidy data. So in this slide where you see here, we can construct a similar tidy data format from raw text of emails that we get. The data is laid out in a rectangular format where each row is information about an email and each column about a feature. Here we illustrate some simple feature engineering using 3 emails. So first feature we can construct is whether or not the sender is in the receiver's contact list. This feature, also marked x1, is a boolean variable that it takes one of the two possibles, true or false, depending on whether the sender is in the contact list or he is not in the list. The second feature counts the number of special characters in the email and we are trying to denote it by x2. Finally, we have the column called spam, which is a boolean which marks whether the email is spam or not. This is the variable that we want to predict using some machine learning algorithms. So this variable is called a response. Other popular terms are outcomes or dependent variable. As a matter of fact, some alternative terms for features are independent variables, explanatory variables, and things like that. As an exercise, you can think of some interesting features that you can construct from the raw data set of the email and see what all can help in doing some feature engineering.